Alright, today might be a little windy. We're actually on the other side of the wall of my shop right now. Still under the main truss system. It's a 40-foot truss with an attic. This is the last 10-foot section. I have no idea if you can hear me at all, but I'm going to try my best. It's pretty windy out here today. But what we're going to be doing is talking about how to actually frame in something that's a little bit weird. I poured the concrete here last August before school started, and this is actually going to become my machine shop. I've got some equipment coming in hopefully this summer, and what we'll be doing is I'm going to move my cutting station, which you probably have seen in the background, over here, hopefully upgrading the saw. I've got a lathe coming in, and I'm hoping to add a mill so I can actually start doing some machining work. But initially, this shop, the shop was only 20 foot by 20 foot. When this is all closed in, this will be a 20 by 40 structure, all usable space. I just threw my pencil because that's what we do with no chance to cut or have outtakes. But with that said, here's the deal. So what I'm doing is, I said, this is a 10 by 20 area. Poured the concrete. It's not perfect. I didn't. So you can power trowel. You guys have probably all seen a trowel. It's a little hand deal, or a bow float, which can stretch out to about 15-20 feet to help get a nice finish coat. The day didn't quite go as planned, so my concrete's not perfect. But the thing is that's okay. It's pretty level. I'm finding places where I screwed up a little bit as I go along. I've had to adjust a few things using a grinder and a concrete abrasive disc, but you know, that's how things go. So today, what we're going to be doing is I'm going to be putting the last couple studs in. I already put this one in. We're going to be talking about some of the choices I made. So these are 6x6 posts that are sunk down into the ground. We didn't pour a footer, and a footer is basically a large chunk of concrete that's poured in place that distributes the load. So if you have a wall that's a concrete wall, what you end up having is a footer that's probably about 1.5 to 3 times as wide as the wall, and it basically gives a nice large footprint footer for the whole house to sit on, so it doesn't settle or sink randomly or weird. So with that said, this is what we call a floating slab. The slab's actually in 3 pieces. There's the main piece. It's just kind of hanging out there. And then most of the weight of the truss system in the roof is borne or goes to ground through these posts. They're sitting on a pier pad, which is a pre-poured piece of concrete. Functions similarly to a footer. But the thing is that it's not poured in place, it's not as heavy, it's not as hard wearing. So these have moved. So with that said, I had to make some decisions. So just a little bit of review for some people and not review, new thing for some others. What we have here, we have our pad. As I said, it's a floating pad. It means there's no wall structure or anything tying it into the ground. It's all sitting on compacted stone. So that's right here. This is a 5.5-inch pad, concrete, poured in place. Then we have, and you can see right here, this thing right here. This is a sill seal, and what that is essentially, I think my dog is going to come visit us, or one of them. See what happens. But that basically allows for there to be some insulation between the sill or the plate, the first plate here, and the ground. Otherwise, we're going to get a lot of wicking of water. Yeah, my dog's coming. Hey, pup. Good girl. Say hi to YouTube. Land. All right, so what we have here, as I said, we've got our plate. We have our first plate, which sits on the sill seal, and as I said, that prevents that direct contact. If this was a house, code has changed a little bit, and I'm not super familiar with it, but I used a pressure-treated plate on the bottom. The reason for that is because it's going to prevent rotting. This structure tends to be not super wet, but does get some moisture. I'm right on this eave right here, and it does get a lot of splash back into this. So whatever I choose to, well, I know what I'm going to use. So I'll get to that in a second. So whenever I put my sheeting on this, the choices I make are trying to keep water out. So I've got my plate here. I've got my other plate right here, right on top of it. And then up here, I've got my top plate. This is different than your standard wall. If this was a new construction where I was building the wall right from the get-go, I would build this wall on the ground and stand it up because a couple things. First off, this thing is not perfectly square and it's not perfectly level anymore. It has moved. That's why we talked about the how this was prepared, how this was constructed. And the reason that that's important to realize is I'm going to make decisions based on that. I went back and forth a little bit on if I'm going to level these and keep them true or if I'm going to measure everything. I decided to do measuring because I'm not that far out of level, and that way I'm a little bit consistent, and that goes back to my sheeting. I'm going to use what's called textured 111 or T111. And that is, you might, I don't think you can see it from the camera angle, but it is basically a piece of plywood that looks like individual tongue and groove panel. So, what are we going to do today? So we've talked about our plates. So I'm using screws. You can nail a lot of this stuff in place. The reason I'm using screws is because this is probably not the last edition. This is probably not the last configuration. It's going to be a lot easier to take it apart for me to modify it if I use screws. Also, because things are not perfect, they're out of sync, out of square. I can draw things in better with that little bit of mechanical advantage. So we'll get to our studs in a second. So we have our plates, top, bottom, and as you can see right here. Actually, I don't know if you can see right there. You can probably definitely see right here. These guys, what I did here is, the other thing that happens, these 6x6s have twisted over time, either from the movement of the ground or from them taking in moisture, because this was all exposed. This was originally part of a wood shed. So with that, the choices I've made, 16 on center, which is your standard stud spacing. I measured from the first outer, I think you can see this, the first outer 6x6, 16 on center will be this one, 16, 16, 16. There's actually there's a bit of relief, oops, knocked something over. There's a bit of relief, which means that there's a little bit of the 2x4 sticking out past the 6x6s on the front of it. The reason I bring that up is because those are choices you have to take into consideration. Do I care more about hitting my plywood all the way across the front surface of that 2x6, or is it more important to have consistent spacing that allows me for it to overlap appropriately? In reality, it probably doesn't matter one way or the other. I tried lining up this other header, which carries the truss, because my plywood's going to go all the way up that. So I tried using that as my guide, and when I lined that up with the outside of the slab, that's kind of what my choice was. I am a little bit out, not too much, just probably about a 1/16 and 8 feet. Not too bad, especially considering how much this moved. So I'm going to show you how to use a new tool today. It's called a hammer drill, or a Hilti is the name brand. We refer to them as Hiltis. This guy right here. And the reason for that, if you look over here, I'm going to switch camera views a little bit. You can see right here, I'm kicking it with my foot, there's a nut and sticking up through a bolt. And I only have my pressure treated 2x4 right here. And with that, I'll move this stool out of the way so you can see a little bit better and get my safety glasses. So the reason for that is we need to actually anchor that 2x4. And if this was a wall that was standing up, I would do the same thing. I would still anchor that first 2x4 and then put my wall up. And what that does is that allows us a mechanical connection from the 2x4 to the concrete. And the reason we want that is because if we don't do that, nails aren't perfect. And in fact, in a lot of ways, they're fairly substandard. And the reason that screws are a really good thing because, as I said, you get that little bit of mechanical advantage. It's really great. You can take stuff back apart, and the likelihood of you shooting yourself in the finger with a screw gun is lower than a nail gun. So I have my mechanical attachment to the plate. And the reason that I'm doing this way, there are different fasteners, there are different ways to do this, but I'm doing this way because to a certain extent it's economical, it makes sense, and then what I can do is I can just screw my next plate on top of that. So Hilti, as I said, we'll refer to this. This is a hammer drill, which means it rotates and hits. I have a specific concrete bit here. The tip is different than a lot of your conventional bits, and that's, again, to allow us to get through the concrete. I've pre-drilled some holes through the top of the plate, and I also have already put my other two anchors in. With that, so I'm ready to drill my last hole. So this guy has a couple different settings. You can have just drill, you can have jackhammer or just hammer, which allows you to use it basically, as I said, as a small jackhammer if you're trying to do some demo work in a tight spot, or you don't have the money to pay for a full-size jackhammer. So this guy, as I said, rotates and hammers, allows us to remove the material necessary. So, as I said, it also does drill and has a slightly different bit configuration. I actually borrowed this one because they are expensive. The bit actually has a locking mechanism in it. So again, a ball style, and then it locks in place. So there's a detent inside. And so instead of having to tighten a chuck, this has a lot more positive engagement so that you don't end up destroying your drill bit or your drill. So let's drill this out, and then I'll talk about the fastener I'm going to use. So, as I said, I pre-drilled that. It takes a little bit longer. As you can see, I'm using the drill to actually take the pieces that I had in there up and out. I've checked my alignment here. I am right where I want to be. As I said, there are a couple different ways to do this. The anchors I chose are a full collared style. What happens is as this tightens down, it pushes it out and actually will hold that in the hole. So I'm going to take this. I've got my nut on the top there. I've got it loose. I'm going to put this in the hole. It's a little bit small, but we'll get it in there. The board has shrunk, is a little bit wet because we had snow last night. So I'm going to go right down there. Got my hammer. Put this in my pocket so it doesn't blow away. And then, of course, I lost my wrench, which is right here. Just an adjustable wrench. These things are great. So what I'm doing is I'm going to cinch it down so that I have that positive engagement of the 2x4. And right now, it's pretty good in there, but this is going to give me, you can hear it moving. This is going to give me a nice, tight fit so that my wall doesn't move. And also, it'll get me my sill seal so that if I do get a little bit of water inside, it won't come into the shop as easily. I've got some issues on the other side because I've got poor drainage over there. And I just want to give this a nice tight and start seeing my washer deflect a little bit. I do that just as kind of a check, but that's where we want to be. So there's that. But now I've got these nuts sticking up through there. So how do I take care of that? Well, I did cheat a little bit. I pre-drilled these. I marked it. So this is just a standard paddle bit. So what I've done is I marked right here. These are all centered at different places along here. The one thing that happened here, my form must have bowed a little bit because I did use the 2x6s as my guide when I poured this concrete. This 2x4, even though it's lined up with the outside edge of each one of these, does have a little bit of concrete sticking out of it. So what I'm going to do here, since I don't have sawhorses, I kind of want to show you this. So this paddle bit is about 50% larger than the screw, the bolts I have there. So I've got this, so they're 4 inches in. One of them approximately centered. I rounded up or down on one of them. And you know, the question is, with that rounding up or down, am I going to get it to line up correctly? So what I did is they're 4 inches in, centered on this 2x4, which is 3.5 inches wide. So 4.5 down, and then at 1 3/4. So let's see how we did here. So I'm going to take that. You can go pretty precise on this. I'm just giving it a good. So one thing I want to do before I move on is I want to make sure my plate is clean so I don't get any anomalies in there. So this is the one I just drilled, and I did do it on the right side. Cool. So we're going to put that down like that. Get our trusty hammer. And it looks like I did it right. Looks like I did it right. So what I'll then do is I'll come back here. I've got my impact. I'll just set one screw in so I don't end up screwing it up later on. Screwing it up with a screw. Okay, so I've got that line there. The other one, I'm just going to pin this end in one spot. So I take my screws. I'm using a decking screw. The reason again for that is because they're designed for outside use. This shop is not perfect. So it is one of those instances where there is water present. So I'm using the decking screws with the thought that something's probably going to get wet at some point. I have this laid out for my studs. And then I'm going to transfer that up top. Because this is out, I'm doing it in place. Same thing with this. I actually screwed up on my you can't really see it from where you are, but I've got a couple crossouts up here. That's rough. It says that you're not receiving enough. Hopefully you get some more, but all right. So, and then this right here, we're going to put our studs in. So I've got my marks, top and bottom. Again, 16 inches on center. So I've got my first one here. I cut they are not load bearing. All the load is taken up in the header above them. That being said, I do cut them so that they have a good, they do have a little bit of load on them. And the reason I do it that way is that reality is you're going to end up in different instances. You're going to end up in instances where you're, I put a little bit of weight on it because it can't hurt. This structure is about 10 years old, and any help it can get, you know. If this was something we were going to put sheetrock on the inside, and we really cared about what we care about our siding looking decent, but if there's a little bit of a waiver, if the vertical detail in the T111 is not perfectly straight or level, it's okay. You still should try to do it right, but at the end of the day, it is a shop, and I'm doing this by myself. There's not a crew, there's not an additional person. The only reason I mention that is there's only so much you can do when it's one person, you only have one set of hands. Yes, you can take immense care, and I recommend doing that every time, especially with furniture and welding and things like that. But there's some instances where a second set of hands makes it go a little bit easier. So do your best. So what I was going to say there is looking at the crown of the 2x4, and what that means is as these dry, they tend to heap up one way or another. So crown, you'll pay attention to that, and that's something for another video if we really get into it. And I actually, in all honesty, I have to check. That's one of those things that I know about it, and I have to look it up every time. And I'm pretty sure there are a couple different schools of thought which side crown out, crown in for different walls. If you want your sheetrock or your siding to have the crown. But anyway, so I think that's where we want to be. I'll double check it. I'm not gonna. I'm not gonna send all these home right now because I'm talking to you guys, and I don't want to, put one in completely wrong. But so what we do is, as I said, I've preloaded these a little bit. There's probably about a 16th. Probably about a 32nd to a 16th, not too long, but so they fit snug, and they're not an exact measurement. So that's what the wall would look like, fully framed. We continue this on in the next two bays, and then I don't believe you can see it from here. There's a final bay in the back, which is a 10-foot span where I'll put 10-foot 2x4s in. So today we went over how to secure our plate. My dog's back. That's nice of her. Hey, pup. We talked about how to secure a plate, our different parts of it. We talked about our 2x4s, some of the decisions that we have to make in framing something that is pre-existing, and then also putting our 2x4s in. Again, since I don't have this awesome camera crew, I can't show you close-ups of oh, this is exactly how oh, there goes my dog into the water. I can't show you the close-ups of and some of the specific decisions. But long story short, this is what I'm going to be doing and carrying on for the next little bit. And the reason for that, as I said, is I'm actually going to put a window in this center bay. So I got to make some decisions there about the rough opening, etc. I'm going to trim it out. And then I've got a heater that's going to go in here, so I'm going to have some wrangling to do. But this is going to be my machine shop. And there goes another screw. We'll see how it goes. So have a good rest of your day.